Norm of a vector. First of all, definition. Let alpha be a vector on an Euclidean space. Euclidean space V. Then the norm of alpha is defined by, हम कैसे डिफाइन करेंगे? सबसे पहले नॉर्म ऑफ अल्फा नोटेशन, नॉर्म ऑफ अल्फा इक्वल्स टू रूट ओवर इनर प्रोडक्ट ऑफ अल्फा. नाउ व्हाट इज यूक्लिडियन स्पेस? डेफिनेशन ऑफ यूक्लिडियन स्पेस. A real vector space has to be a real vector space v comma plus comma dot together with a real inner product is called an Euclidean space. मतलब कि एक ऐसा रियल वेक्टर स्पेस जो कि इनर प्रोडक्ट के सारे प्रॉपर्टी सेटिस्फाई करे, उसे हम यूक्लिडियन स्पेस बोलेंगे. नाउ थिंग्स टू रिमेंबर. नंबर 1, ए नॉन नल वेक्टर अल्फा बिलोंग्स टू वी. अगर अल्फा एक नॉन नल वेक्टर होगा, इज कॉल्ड ए यूनिट वेक्टर. यूनिट वेक्टर कब बोलेंगे? इफ नॉर्म अल्फा इक्वल्स टू 1. सेकेंड वन, लेट अल्फा बी ए नॉन नल वेक्टर in V, then beta equals to 1 by norm alpha into alpha is a unit vector. We know that, हमें क्या पता है वेक्टर के लिए u cap equals to u vector divided by magnitude of u vector. We know that, where u vector equals to u cap equals to normalizer vector, u vector equals to non-zero vector, and magnitude of u equals to norm or length of vector, length of u. So similarly we replace magnitude of u by norm function. Example, let alpha equals to 1 2 3 4, beta equals to 1 1 1 1 belongs to R4 with standard inner product. Now what is norm alpha? Norm alpha का value is root over inner product of alpha equals to root over 1 square plus 2 square plus 3 square plus 4 square equals to root 30. Similarly norm beta equals to root over inner product of beta, that is equals to root over 1 square plus 1 square plus 1 square plus 1 square equals to root 4 equals to 2. Now the second example is, let fx equals 3x minus 3 5 and gx equals x square on p of r, and Inner product of f comma g equals to integration 0 to 1 fx gx dx. Now question क्या है? Find inner product of fg, norm of f and norm g. Now solution of this. Now the solution of the previous question is inner product of fg equals to integration 0 to 1 fx gx dx, that is equals to 0 to 1 3x minus 5 into x square dx equals to 3 by 4 x to the power 4 minus 3 by 5 x क्यूब. इंटीग्रेशन करने के बाद लिमिट अपर लिमिट लोअर लिमिट 3 by 4 minus 5 by 3 equals to minus 11 by 12. Now for the second one, inner product of ff equals to 0 to 1 integration. After calculating we get 13. Now norm of f equals root over inner product of ff equals to root 13. Similarly, inner product of gg equals to 0 to 1 gx gx dx equals to 0 to 1 x to the power 4 integration 0 to 1 x to the power 4 dx equals to, after integrating we get x to the power 5 divided by 5 0 to 1 equals to 1 by 5. Therefore norm g equals to root over inner product of gg equals to 1 by root 5. Now primary properties of norm of a vector. First, let V be an Euclidean space. And C belongs to real number, alpha belongs to vector. Then first property is norm of C alpha equals to mod C into norm alpha. Solution. Norm of C alpha square equals to inner product of C alpha that is equals to C square alpha that is equals to C square norm alpha square. Therefore norm of C alpha equals to mod C norm of alpha. Now the second property is norm alpha greater than 0 if alpha not equals to theta. Solution. Here given that alpha not equals to theta, therefore inner product of alpha greater than 0, that is imply norm alpha square greater than 0, that is imply norm alpha greater than 0. Hence proved.